Well, hello and good morning, everyone. Thanks for having me. I'm going to be talking to you today about karst. And before we move on, let's just get this out of the way and define what karst is. Karst is a type of topography formed by the dissolution of carbonates. When I talk about carbonates, I'm talking mostly about limestone and dolostone. Before I like to get started, I think it's interesting to talk about sinkholes in the news. These are all videos that are a few years old, but I think most of us here in Kentucky have heard about the Corvette Museum collapse, and I have this one embedded into the screen here, so if you just fast forward to the end, you can see the internal cameras caught it on footage. This happened about 5 o'clock in the morning at the Corvette Museum back in 2014. There's some other videos here showing a guy who was on a golf course and he got swallowed up by a sinkhole. It turns out that the audio wasn't working for whatever reason on the video, but basically it was on CNN News a number of years ago. They took a look at the golf course and had a picture of the guy and interviewed him, and he's okay, so that's good news. Obviously, sinkholes have been going on for a very long time. It just seems like the one with the Corvette Museum brought it to light with regard to like national attention, and then people started paying more attention, and there were suddenly lots of shows and news stories about sinkholes. So what's the deal with water movement in karst? And I think this is an important point. Groundwater movement in karst, and when we say karst, we're talking about rocks like mostly limestone in Kentucky with some dolostone. There are other rock types, which we'll get to, is much different than water moving through other types of rocks like sandstone, sediments, clays, and shale like we have in this area. In karst, groundwater can move very, very fast, on the order of miles per day. I've done studies on this, which I'll show you in a bit, as opposed to water that's percolating through tiny sediments. What in this section I generally call non-karst sediments, which move very slowly at perhaps inches per day or maybe even inches per month. So how does it compare? In a granular aquifer, in other words, a non-karst aquifer, you often have slow-moving water. It is isotropic, meaning it's moving away from a central point at an even rate, and it's homogeneous. In a karst aquifer, the water is often fast-moving. It's anisotropic, meaning that it can move much faster in some directions than other directions. If you look over here to the diagram on the bottom right, you can see that the water moving through the conduits, for example, to the left, to the right, or up and down where there is a conduit would be much faster, similar to water moving at the surface compared to it moving through the rock layers. And it's heterogeneous. And I have down here at the bottom, some do not know the difference. What I mean by that is some professionals who went through school and got a degree in engineering or geology or in environmental science, sometimes they don't have a strong background in karst. So if they're put on a job site in which they're required to know a decent amount about karst in the subsurface, it's important that we give them that information about karst. Otherwise, it could lead to buildings and roads and bridges and things like that being poorly constructed. Here's a karst map of the United States. As you can see, I'm going to focus mostly on Kentucky because that's where we are. You can see the green and the dark green areas are indicative of areas where you have karst underlaying where you are. So you notice that around the Lexington, Louisville, Northern Kentucky area, as well as the dark green area out in Western Kentucky, all those are areas where you can have karst and cave formation, sinkhole formation, things like that. Here's a map from the Kentucky Geological Survey of karst development in Kentucky. About 55% of Kentucky is underlain by rocks that could develop into karst, and about 38% of the state has at least some karst development, according to the Kentucky Geological Survey. The dark blue areas are the areas for highest karst potential, which is around the Lexington greater area, to some degree Louisville, and there's this horseshoe shape around the Western Kentucky area, of which Mammoth Cave is in, which is the longest cave system in the world at approximately 410 surveyed miles in that range at this point in time. It's the longest cave by far in the world. So what are the types of carbonates? Limestone, I think, is safe to say is the most important one, at least for around here. It's calcium carbonate. You also have dolostone, which is a fairly common carbonate rock. If you metamorphose those, you get marble. And if you look down here at the bottom, this is just the chemistry of it. If you take calcite, which is the mineral that makes up limestone, and you add slightly acidic water to it, as water coming down through the atmosphere as rainfall, or water getting a little bit more acidic as it runs through soil, etc., that yields calcium ions and bicarbonate ions, which, if that is deposited somewhere, that may be a stalactite or a stalagmite that you may be familiar with, that you've seen in caves. It can also form certain types of limestone rock. And this is the process called dissolution. This is just a generic diagram of a highly karstified, if I may use that word, a highly karstified environment. Just some examples of features that you would see. A disappearing stream. You have a dry cave and a wet cave. Almost all caves are wet caves as they originally form. You have a karst spring. It shows up here as acid rainwater runs down and start dissolving those cracks, and they become larger and larger over time. An important point is there's a difference in the types of groundwater flow. So on the left, you have a convergent system, which is karst. Let's take a look on the right first. I think this one is the one that's most intuitive. A divergent system. So if you pour water out on your yard or in a sandbox, or just in most types of geology around the world, that water is going to diverge. It's going to go away from a central point. And that's what happens a lot of times, but that's what happens in a non-karst environment. Think of sand or sandstone, typical rock type like that. But if you look over here on the left, karst is different. Karst is a convergent. It leads to a convergent system. Think of the pipes in your house, the pipes that connect your sink, your washer, your tub, your shower. All those things are connected, and they lead to bigger pipes that eventually go out to the wastewater system for the city. And that's similar to what a karst system is like. If you look down here on the bottom left, you have all these little cracks and crevices, and as you go downstream underground, they get bigger and bigger as they dissolve away. So all of that stuff that's coming from the surface comes together convergently. So if you have wells, or you have some sort of large non-point source pollution, all that could make its way down to a convergent karst system, which would have different impacts than it would if you had a divergent system. So that's why I say it's so important that environmental geologists, environmental engineers, environmental scientists, etc., have a good understanding of karst. I'm just going to go through some fun pictures, some springs, caves, sinkholes, sinking streams, and some studies that we've done with regard to karst features. This is a karst spring out around the Mammoth Cave area. Oftentimes, karst springs can be quite larger than springs in other types of environment, because these karst situations can erode large areas underground, and you can have big streams. Here is a cave down in Pulaski County where I did my master's thesis. Of course, everybody knows what a cave is, but caves are formed through this dissolution process that we call karst. Here's stalactites, stalagmites. Stalagmites are the ones on the bottom. Stalactites are the one on the top. When they grow together, they form something that's called a column. Many of you have been to Mammoth Cave or some other cave, and you've seen these really cool cave features. Sinkholes. Here is a small sinkhole. You can have, this would be an extreme, like an extreme example, a very extremely large sinkhole. We don't have sinkholes this large in Kentucky most of the time. Something I do want to point out is that historically, people used to dump trash in sinkholes because it was just kind of out of sight, out of mind. You don't really think about it. I think we've done better at this post-RCRA in the 1970s. Laws are against these things, but There are still people, unfortunately, who dump old refrigerators and old cars and just garbage into sinkholes. And that's absolutely the one of the worst places you could possibly do this, because it is directly in contact with the groundwater, and it can lead to groundwater contamination. So you don't want to do that. We want to encourage and educate people that that is not the place to dump garbage. What about sinking streams? This person here is dumping dye into a stream. As you follow the stream along, it sinks. Now, why would this person be doing this? They're doing this so they can trace where that water goes. And it might seem silly. It might seem like, well, it probably just comes out on the other side of the mountain, or, probably just comes out somewhere else nearby. That's not always the case. If you look at topographic maps and try to figure out where sinking streams are going, and you actually do a dye trace, it turns out you're wrong more often than you might think. So we do these dye traces to see where it's going, how long it takes to get there, and things like that. And they're really interesting studies to do. I've done a lot of studies like this with my students at different research institutions. Students seem really interested in this subject. I think one of the reasons why is it's fairly easy to do, and it's somewhat intuitive as to how this might work, and they really get some hands-on experience in the world of geology and hydrogeology. Here's just one example of a study I did 10 plus years ago in south central Kentucky. These areas here, this area around the top, if you can see where my mouse is moving, the areas around the top here, we had 10 monitoring wells installed as a part of an EPA grant. And we wanted to inject dye in these areas and see where the dye went. And we had monitoring stations at Big Sink and Short Creek. The summary here is that dye showed up in some of the wells, other wells it didn't show up in, and this was indicative of the fact that monitoring wells are not reliable in Karst. It showed up at Big Sink and Short Creek faster than it showed up at some of the on-site monitoring wells. Historically speaking, back when we didn't really fully understand Karst and the groundwater movement in Karst, we had regulations that were written that excluded Karst. So when you had environmental engineers and environmental geologists out in the field that didn't really understand the dynamics of groundwater Karst flow, they used these monitoring wells to indicate whether or not contaminants had moved through that area, and what the water, we call that potentiometric surface, the surface of the water level in the wells. It turns out that those aren't that reliable in Karst, so you have to know more about that to fully understand a Karst environment. So if you're doing dye tracing, what kinds of questions might that answer? Where are the groundwater divides? It's important to know where the groundwater divides are, both in surface water and groundwater. What direction is the groundwater moving? Dye tracing can tell you that. It can tell you how long it takes to get there. And one example over here I have in West Lexington, you have this truck that's driving down Harrodsburg Road, and we have a line here. We've done a dye trace. Why would we want to know this? If the truck has an accident and it has a spill, if we have done these dye traces ahead of time, we can know where this groundwater contamination is going. We can warn the residents. If we have not done that ahead of time, we would not know the answer to that question. And the evacuation radius might be quite much larger than if we know where it's going. And I just like to show some examples of cave creatures. Here's some bats. There are lots of bats in caves. They usually won't bother you. Unfortunately, we have a problem of bats with white nose syndrome. Cave shrimp, cave fish, they've evolved to be eyeless and colorless. They don't need as much energy way back in a cave where you don't have a lot of food. Cave crickets, they're fairly ubiquitous, but they won't bother you. Here's some pictures of South China karst, a large sky hole, the Madagascar dissolution features. This is a very large karst spring coming out near the Mammoth Cave region. Here's an unfortunate place where somebody built a house directly over top of a cave that became a sinkhole. This is central Kentucky, the rolling hills, where you have quite a bit of karst. This is the Sinkhole Plain out by Mammoth Cave. This is a cave in south central Kentucky called Stab Cave, where you have all kinds of cave features, which are called speleothems. It's just kind of an overall word that encompasses all cave features like stalactites, stalagmites, pooling, and all those sorts of things. Here's an example of a road that was built in a place where it should not have been built, or proper engineering had not been done. This is a place called Short Creek down in Rockcastle in E County here in south central Kentucky. It's a privately owned area that's really neat. People get married there, have picnics. Just a really cool place. The river flows out, or the creek, excuse me, the creek flows out of one mountain and into the next. About 50 feet span is the only time that you see it above the surface until it finally discharges into the next biggest river. This is a highly karstified limestone environment, an area with lots of speleothems, the drapery room in Mammoth Cave, another road that was built in an unfortunate place, another road looking out from a large sinkhole, and the Mammoth Cave region. I have a variety of Karst videos that I show in class, but of course we don't have time to do that here. That concludes my talk. Thank you very much for your attention. I hope you enjoyed it.